Uh, Hello, everyone. I will be discussing about this problem called Prepend and Append. Um, in this problem, we are given a binary string, and we are allowed to perform um, a type of operation in that given string. We can only add. Um, it will be a binary string consisting of zeros and ones, and we can add um, in one operation we can add 0 or 1 or maybe vice versa respectively to the first and the last position. And what we're gonna have to do that and you can perform some operations and come up with a string. What you will be given is the final string, and you're gonna have to find the length of the shortest possible string um, that you could have started with. Now, there might be cases where it's not actually possible up until some moment where you have started using these operations. I have documented some examples to make sure that we understand it perfectly. Now, here's the thing. In this example, what do we think would be the shortest possible string from where the operations begin to start it applying? So it will be the logical solution would be to find out such a mismatch, and it should be the largest possible positions mismatch. What I mean by is that we let's say okay, this string is of length 1 2 3 4 5 6 7 8 of even length, and what you would think is that you would start from the middle ground of the string, and as it's stated that the operations are constructed from appending in the first and in the last position. So we're going to take a look at the mid of we're going to start our iterations from the middle ground, as in from here and here in the even length, and of course in the odd length there will be one single character that will be remain. So we're going to start, let's say for this we're going to as it's an odd length, we're going to start from here and here. Now what are we going to do? We would be comparing whether these two characters um, are equal or not. What would be our logical goal? A logical goal would be to find such maximum positions from where there's a mismatch, or where there is not, which is not satisfying the conditions. Meaning, we have to maximize and return a substring that would be where the two of these pointers character value would be equal. Why? Because that would be mismatching the condition that they are given. For example, if I take a look at this string, as you can see, okay, there's 0 and there's 1, so there's a possibility that from here, this could be the shortest possible string from where the you know uh, from where the operations were started from applying. This could be the shortest possible string that the operations were being started applying. Now, there could be another case where we have. Now, after doing that, we're going to traverse the pointers. So this point will jump on here and here, and we're also going to see whether they are equal or not. They're not equal, which means still the operations uh, were perfectly organized, and similarly, it is also satisfying the condition, and also satisfying the condition here. So we could state that what would be the answer for this string? the answer would be 0 because this is the minimum possible substring. I mean, from where the operations were started, because it was all from the beginning that the conditions were applied and there was no mismatch. Similarly, if I take a look at this string, 1 2 3 4 5 6 7 and 8, okay, definitely, it's a even length. I will start from the middle ground and I will see, okay, if there's a mismatch, so still our possible answer is 0 up until now because they're not equal. There could be a possibility that it was starting from the empty point. But you see, after I move the pointers back and forth, the left and the right pointers, you will see that it's equal. So it's not matching the condition. So our answer would be at least, up until now, it would be at least of length 4. And we're going to traverse again. And we'll see that we can see another mismatch. So the answer increases. This is the shortest possible substring up until now. Up until before coming in here, the answer was 4, but now it's 6. The answer is 6 now. And again, if I move on, we can see a mismatch. We're not going to update it because it's we can see that they're satisfying conditions. So what would be the answer for here? For this example, what would be the answer? The answer would be of length 6. 1 2 3 4 5 6. See, that will be the shortest possible string from where the operations were started applying. And similarly, for the odd length string, there would always be an answer, and that answer would be 1. And then we incrementally increase if there is a mismatch. Because why it's 1? Because it's an odd length. There would always be at least one string which will be different, which will be, odd, or should I say single. We cannot apply those operations in here. So in the odd length, the minimum answer would always start from 1, and then incrementally, if there's a mismatch, we would increase our answer accordingly. If I take a look at the code section, this is the code section here. I will take best case, and I'll take the string. I would say that for the answer n equal to 1, the answer is 1. That's just could be a corner case, but I guess I could have. I guess I didn't need it in the first place. I could have done that generally speaking, like in here, but whatever. But you see, the n is, when the n is even and the n is odd, I'm just setting up my left and right pointer and the initial answers. Now after that, that's the tricky point. That's the thing where if there's a mismatch, if it does not satisfy the condition, meaning if the first and last pointers up until now, if they're equal, then I have an answer up until now, because that's the minimum and shortest possible substring. I will update it. I will update the answers as far as I can go, and that will be my final answer. That's how I will be solving this problem.